All right, welcome back. In this video, I'm going to talk about how we value European call options and, by extension, put options as well. So I'll start by discussing the Black-Scholes option pricing model, one of the most fundamental models and formulas in all of finance. We'll talk about how that model is used, and then I'll talk about how we actually value American options, and then ultimately we'll talk about put-call parity and the put-call parity formula. Okay, so this is the Black-Scholes option pricing model. This model is one of the most important models in all of finance. It's a Nobel Prize winning model. It was developed, just to give you some background, by several different researchers. So Fisher Black, Myron Scholes, that's where the name comes from, and then Merton Miller, I believe, also assisted on a related paper. Now, this is a Nobel Prize winning formula, so Myron Scholes and Merton Miller, I believe, got the Nobel Prize for this. Fisher Black, unfortunately, passed away before he could receive the Nobel Prize. Now, what does this thing do? Well, this thing essentially says that the price or premium for a call option with an underlying stock price of S and time to maturity of T is equal to everything that we see here. So this would indicate a normal distribution with D1 here times the underlying stock price minus the normal distribution of D2 here times the strike price times e to the power of minus the risk-free rate times the time to maturity. So very long formula, very, very impressive derivation. This is something that you would derive in like a Master's of Finance class. It's a very, very, very important formula. Okay, so what are the components in the Black-Scholes option pricing model? Well, there's only really 5 main components in this model. We have time to maturity, or capital T minus little t, so later time minus current time. And we have the underlying stock price, so that's at S. Strike price, just as it's been in all the other lectures, is K. Asset volatility, just like with stock volatility, it's sigma. And then our risk-free rate is R. Now, all of these you'll see in the option pricing model, and they all have a very straightforward relationship with the price of this call option, C. So time to maturity, if that increases, that's going to increase the value of the call option because you have more time to exercise this call option. You have more time for it to be in the money. Stock price, if the stock price, the underlying stock price for this option increases, well, that's going to increase the value of the call option because you're more likely to be in the money. Strike price, if that increases, then you're more likely to be out of the money. So increases in the strike price are going to decrease your call option value. Asset volatility, if that increases, there's a greater chance you're going to be very, very large into the money. And if you're very, very outside of the money, you just wouldn't exercise it. So asset volatility has a positive relationship with call option value. And then lastly, the risk-free rate has a positive relationship with call option value. Okay, now you can actually value a put option using the Black-Scholes option pricing model and the put-call parity formula, which I'll touch on in a second. But basically, a lot of these factors are exactly the, they're similar. So the time to maturity, you have more time to be in the money with a put option, so positive relationship between time to maturity and put option value. Stock price, now we're reversed. So if the stock price is higher, this would decrease the moneyness of the actual option. You would be more out of the money with the put option. Whereas with the strike price, if the strike price increases, then you would be able to sell your underlying stocks for a higher price. So higher strike price, higher put option value, or aka higher put option premium. Asset volatility, this is going to increase the in the moneyness that you would be in the case that the amount that you would be in the money because it's increasing the volatility of the underlying asset. So higher volatility has, or therefore higher put option value. And then higher risk-free rate, generally we see lower put option values. Okay, so let's go ahead and take a look at this in a very, very quick example. Okay, so here we go. I have this Black-Scholes option pricing calculator right here. So what this does is it essentially plugs in all of the 5 primary components for the Black-Scholes option pricing model, and it spits out the value of a call option. So, let's say we have the stock price right now. Let's say it's, I don't know, $20. We know the strike price is, we'll say $18, and number of years to exercise is 1, and our risk-free rate is 3%. Standard deviation is about 30% is fine. What this does is it calculates all of the different components that we have here. So, we have our normal distribution, and then it spits out, both of these normal distributions. And what we get is essentially the value of the call option. We're just literally plugging in values for each, for S, K, R, T minus T, and sigma. So there we go. The higher the strike price is, the higher the stock price is, watch what happens to the value of the call as I go from 20 to 25. I went from about $3.70 to about $7.88. Now, other relationships that I just mentioned, they are exactly as I mentioned. So if our strike price increases from 18 to 26, watch what happens to the value of the call option. It falls from 788 to 288 because now we're less likely to be in the money at expiration. So that's that. Basically, Black-Scholes allows us to calculate the value of a European-style call option. Now, you might be wondering, how is it calculating the value of a put option? Well, there's a very straightforward formula out there called the put-call parity formula. And what this says is that you can create a synthetic stock using a call, a put, and a bond. And here's that actual formula. So the put-call parity formula says that if you know any 3 of these components, so stock, the call option on that stock, the put option on that stock, both with the strike price of K, and a bond with a face value of K, if you know any 3 of those, you can work out the 4th, or what the 4th one should be worth. So this is just the present value of the bond with face value K, so it's K divided by 1 plus your risk-free rate to the power of T. So this is how we calculate the value of a put option using the information we had in that Excel spreadsheet. This is a very, very important relationship here, and so let's use it in an example. So the current price of a stock is $115 a share, and you also know that the call and put prices of stock with strike price of 105 are 17 and 5 respectively. Risk-free rate is 5%. Use the put-call parity relationship to determine whether there is an arbitrage opportunity here. Basically, when I say arbitrage opportunity, what I mean is if these things are out of line, in other words, these 2 sides don't add up, we could potentially short one side and take the long position in the other, and we would have a riskless profit here. All right, so let's see the information. We have the stock price of $115. We have the call price, or price of the call option, of $17. Put price is $5. Our strike price given was 105. And what this says is that our stock price it's currently 115, but our synthetic stock should be call price minus the price of the put plus the present value of this bond with a face value of K. So the synthetic stock should be worth 112, and the current price is 115. What this tells us is that this stock is overvalued relative to what it should be given the other components. So this is why we care about the put-call parity formula. It allows us to work out what the 4th component should be given the 3 other components. So since current share price is 115 instead of 112. We have an arbitrage opportunity. We would short the stock, and we would short the put as well. Notice the negative sign here. We would buy the call option and buy the bond, and at maturity of the bond and the call and put options, we would have a $3 arbitrage profit. Okay, so you might be wondering, this is great, but how do we value an American call option? We've just touched on how we value a European option. Well, American call options are a little different. Because you can exercise them at any time, what we typically use is a more complicated model. We typically use a binomial option tree to value American options. So in class, we might actually go through one of these, but I figured, for simplicity's sake, we'd just stick to Black-Scholes. But yeah, there is a separate model that we very often use to value American call options. Okay, let's summarize. The Black-Scholes option pricing model is one of the most important models in all of finance. It's used to value European options, primarily the European call option, but if we know our put-call parity formula, we can back out the price of a put option with the same characteristics. We do have another way to value American options, and that is the binomial option pricing model. And put-call parity allows us to value put options and calculate an implied stock value. So with that, I'm going to conclude, and I will see you on the next video. Thank you.